So, hey guys, my name is Nipendra and I'm founder of Cloudwiga. And today we are going to look at all about virtualization. We'll look at the overview of virtualization and how how it is very impact in our cloud ecosystem here. So this particular webinar is a part of the 10 webinar series, as you would know. So we did the last webinar on Intro to Cloud Computing, I think 2 weeks back. And today we are doing on virtualization, and then we'll continue on this order. So idea is that once somebody goes over all of this webinar series, then you will have a good understanding of what a cloud is. And eventually, if you have to build your own cloud on your own premises, at your own home or in your underlying infra, how you can do it. And once you have understood that part, you can basically use any cloud provider. So what happens is typically when you log into any cloud environment, be it AWS, Azure, and so on, there you're going to use some of their toolings to use their services and so on, but you don't know what is happening behind the scene. But once you have understood what is happening behind the scene, things become very straightforward, and then you can use any of the cloud after that. So that's something which we should be doing in the entire webinar series here. So my name is Deependra and I'm founder of Cloudwiga and have close to 2 decades of industry experience and worked with different companies, primarily with Red Hat in their Pune and Bangalore office. I authored a book on Docker Cookbook in 2015, and then also published the Kubernetes courses for Linux Foundation and other courses as well. I also organized the Kubernetes community Bangalore here, which is going to be scheduled in this June, 2nd and 3rd of June in Bangalore. So if you are around, do join this particular event as well. Okay, this is what we're going to cover today. So we are going to look at what is virtualization, the type of the hypervisors we have, then para, full and hardware assisted virtualization, memory and IO virtualization, live migration, cloning and snapshots. This is what we are going to cover in today's session. And this should actually give you the entire understanding of what virtualization is, how we're going to use it in our environment. So I'll request all of you to just focus for the next 1 hour on the screen and understand this particular part very clearly, with a very good interaction and so on here. The idea is that once you have understood this particular virtualization part clearly, you will know how the virtualization has been done on different cloud providers. So typically when you go to AWS, you request for a VM. And that VM is given to you by some means behind the scene. So this is what is happening, what we want to cover today. And that's really going to be helpful for you in your career and so on. So for next 1 hour, please focus only on the screen. You can take aside your phone and so on, keep it aside, and just focus on this particular webinar, what we're going to cover here. Okay, so what is virtualization in a very general terms? So it is in the computing world, right? So it is creation of any virtual version of something. So for example, you can virtualize your hardware, storage, network, and so on. So we can virtualize any of these things and then give it to different instances or different applications what we have, right? That is in terms of what virtualization is. Now, why somebody would prefer the virtualization? The very basic reason for that is getting your resource utilization better, and then you can be more scalable and so on. So here are the 2 diagrams what I have on the screen. The first is in which we are using the bare metal, which means you have taken your hardware, and on that hardware you deploy the OS, and then you run your application on top of it, correct? So there's app 1, app 2, and MySQL running on the same hardware with the help of the same OS. Now, here a few things can go wrong. So for example, if the application 1 start using all of the memory, right, of the system, then it can potentially basically consume the entire RAM of the system. And then it would happen that other applications are not having enough resources to perform different operations. That can go wrong unless you configure the memory limitation and so on there. then what can also happen is this one of the application get crashed, right? It can also again take down the entire OS and other applications as well. So that can go wrong if we deploy the multiple application on the same hardware. These kind of issues can come up. Now, on the right hand side, you can see we have the virtualized system in which we have a hypervisor, which basically emulates the hardware for us. And after getting those hardware, we create the different VMs. So we take our guest OS, and on that guest OS, we deploy our application. So here we have the guest OS, and on top of that, we have the app one. Similarly, on the second guest OS, which can be Linux, Windows, or whatever. And on that, you have deployed our app 2 and MySQL there. Now here, if let's say one of the application like app 1 start consuming resources, first of all, it can not go beyond the boundary of your guest OS. So whatever RAM you have given to the guest OS, let's say 2 GB of RAM, then it can consume at max that 2 GB of RAM only when you create that application on that VM, right? Now, if, for example, if the if the application 1 crashes, then also it is going to just affect that app 1 only. The app 2 and MySQLs are going to be not affected from this. And then we should be good there. Hope this makes sense. Then we can also go back up. Sorry. Yeah. So we also get flexibility and scalability. So we can quickly bring down our applications or the VMs on the fly if we use virtualization. Then it is very helpful for disaster recovery and high availability as well. What do I mean by that is, so when you are creating these VMs, you can easily migrate them, so which I'll talk about later. So for example, you can have multiple machines in this environment, and then you can move the VMs from one to another place very easily. And you can also kind of configure that, okay, I would deploy my applications on 2 different machines altogether. And for whatever reason, if one machine goes down, the VM running on other machine can take over, and then it would serve my traffic as well. So we are going to kind of have all of these benefits if I'm going to use virtualization. Now, there are 2 kind of hypervisors. We also call them as virtual machine monitors or VMM. So both terms you can use interchangeably, whichever you would wish. So here in the type 1 hypervisor, it directly runs on the hardware. So what we are saying is, you take your physical machine, whatever you have, and you can deploy the hypervisor directly on top of it. And that becomes your type 1 hypervisor. It does not require any OS per se. But in terms of type 2 hypervisor, we require first of all the host OS, and then we'll deploy the hypervisor. So like VirtualBox is the example of type 2 hypervisor, in which we would first have the host OS, hypervisor, and then we can have our applications deployed on top of it, or the VMs deployed on top of it, and then in that we have the apps running inside that. Now, if I kind of take a step back, in general, architecture of x86 architecture, what the CPUs we have, of these CPUs, when we run any of these applications, we kind of divide these applications into different categories. So we have different rings which we kind of put through our CPU. What we have, we can have ring 0, ring 1, ring 2, and ring 3. In the ring 0, we run our kernel, the OS part of the system. And then think about on the ring 3, you would run your user application like a browser and so on. That would be part of your ring 3 there. And then ring 1 and ring 2 can be used as required by different environments. But ring 3 are user applications like your browser, editor, and so on, while the kernel, which works with your hardware, is going to be on ring 0. So if I look at how does the applications communicate with the hardware and what role does the OS play or the kernel plays here. So think about your application which you are running. Let's say you are running an application of some kind of editor there, right? And or whatever application you are running there, right? And it requires some access to the hardware. For example, you are typing something, right? Now, when you type something, you have to type by the keyboard, right? So what happens is this user application requires some hardware access for you to write on the via your keyboard and so on. And in that case, what happens, you'll send an interrupt or something that's going to happen. And then the OS, what you have, the kernel, what you have is going to handle that, because it would have a device driver of a keyboard or a mouse and so on, and then it can interact with it. So ring 0 is actually going to work with your hardware and get your things done. So the user said that type something, that typing is going to happen on our system via the keyboard and some other means. That is something which OS has to take care of it. So far, I believe you are with me. Now let's see what we're going to happen if we deploy virtualization, right? So what we are saying in this case is, let me go back to the previous slide deck here. Now, if you look at here, when we deploy the guest OS on our hypervisor, now if you look at when I am talking about as a guest OS, right, I would kind of think that I have everything, right? Like I would like to have access to all the rings, right? Because I am the guest OS, and I would assume that I am having the entire access of the hardware, right? But in general, though the guest OS would want to have all of those rings in control, but at the same time, if you look at from the perspective of hypervisor need to share the same resources with multiple VMs, correct? That is something, the challenge what we are going to get when we go towards virtualization. Why? Because every guest OS would want to see or would want to have the access of everything, all the hardware access and everything. That's what it wants, right? But as a responsibility of the virtual machine manager, VMM or hypervisor, I would need to share the same resources what I have on my hardware level, right, with all the VMs. That is the challenge what we need to kind of solve when we deploy virtualization. In that, we give every CPU or every VM respective access of the CPU's disk or whatever. At the same time, we kind of run multiple machines simultaneously. Now, when you deploy these virtualization, what few things can also happen there is, one is the instruction what we run, right? So when I'm assuming that I am the guest OS, I have the full access of my hardware, but I may not have eventually, right? Because some instructions which I'm going to run as a guest OS, I assume that I have all the access. So if you look at a bit of a step back, right? So we have the CPU. On the CPU, we run instructions, right? We have registers of that, and we put that some operands and all that stuff, right? And our registers perform some operations there. Now, let's say if I'm having instruction on my guest OS that basically wants some privileged access to the hardware. But as we discussed earlier, if you are deploying the virtual machine, you are going to have that access via the hypervisor. You're not going to have that access directly to the hardware, correct? So now we should have few different ways by which we can implement this virtualization in our environment. There are different ways by which we can deploy virtualization. One is the Paravirtualization or OS assisted. Second is full virtualization, and third is hardware assisted virtualization. So we're going to look at brief about all of them. So remember what the problem which I said, that some of the instructions when I run from the guest OS, I may not have access or I may not perform directly on the hardware what I have, because there's a layer in between of the OS what I'm going to have there. So what happens in that case is when I'm deploying the Paravirtualized OS, what do I mean by that is because I cannot run all the instructions. So on the hardware as a guest OS, what I'll do is I'm going to change my code base. So some of the guest OS what I'm deploying, I would change their code base and then run all of those privileged operations via the VMM or virtualized or the hypervisor what we have. So we change our guest OS to basically perform all the privileged operations via the virtualization layer or via the hypervisor what we have here. So think about this similar system calls what we have in Linux in general or any other OS, that we have user space which of the kernel space here. The difference here is, here we are doing between the two OS here, the Paravirtualized guest OS and the underlying hypervisor what we have here, right? So in this case, what we require is we need to change our guest OS software. So again, let me kind of take one more step back, previous step which I talked about earlier, that the guest OS cannot perform all the privileged operations to my hardware because it is virtualized, correct? Now, one way of handling the problem is you tell your guest OS that when you talk to the privileged operation, you are basically passing the request to the hypervisor there, and hypervisor will take care of it. So in this case, the OS code, the guest OS code we have virtualized, and that we are going via the hypervisor layer, which we are going through. And in this case, my guest OS is aware that I am being virtualized. I am not something having the full access of my hardware. I am virtualized, which means that to run the guest OS with the Paravirtualization environment, I need to change my my source code of my OS there. And then the example of this is Zen Hypervisor, which is going to be implemented, or which implements by the Paravirtualization setup. Now, this is basically very effective way of doing things because there's going to be much more faster as compared to other mode, which I talk about just after this. So here, because our OS knows that I'm being virtualized, I perform my operations accordingly. And then that was going to be faster than the full virtualization mode here. Now, what happens in this case is, in this case, we don't change our source code, but what we do here is whenever the our guest OS wants the access to the hardware, we do the binary translation on the fly. So here we are not modifying our guest OS source code. We would say that, okay, you bring it whatever you have. You bring it your Ubuntu, Fedora in general, run as the guest OS. What I'll be doing in that case, whenever a privileged operation is being asked by the guest OS, I'm going to translate them on the fly and run it under my hypervisor. So in this case, you can think of there is some kind of conversion happening at the runtime. And that conversion would take some time because depending on instruction, you would translate them and run via the hypervisor there. And that may require some resources, and then will take a performance hit. So if we compare between the full virtualization and Paravirtualization, Para is going to be much more faster because it already knows that I am being virtualized. So I'll be much more, I know what to be done next, right? Because I'll just call this particular next instruction in my VMM or the hypervisor what we have. But in this case, you have to kind of transfer on the fly as per the instruction coming into place. And that on the fly translation requires some resources, and that's why it is going to be slow. Yeah. But the benefit of this is you are not modifying any of your guest code, or your actual ISO or actual VM from different distribution would run as it is. The example of this is VMware Workstation, what you may have used. Now, the next thing comes is hardware assisted virtualization. This is what is being used in the recent times. And typically all the hardwares, what you're going to get now in your laptops, desktop, and so on, they are primarily going to have this support inbuilt into it. Now, the idea behind hardware assisted virtualization is that we are going to have additional 4 rings for my virtual machine as well. So there is a flag called VMX flag, and this VMX flag is being built into your hardware. Now, what it does is basically have, so when you go in the VMX mode, in that VMX mode, we have 4 different rings, the similar way of my host system. So here, if I'm running on my VMX mode, I'm going to have ring 0, ring 1, ring 2, and ring 3 for my guest OS. And then I'm going to have the similar 4 rings for my hypervisor as well. Now, what happens with this is the guest OS kind of understand, okay, now I'm the kind of super king or whatever, right? Because it has now got that I have the ring 0 access and I can perform everything as it is. So think about if you're deploying an OS, and when the OS want to perform something privileged operation, right? And if it can't do, it's going to have some side effect. And that is what we saw in the case of Paravirtualization and the full virtualization, how you're going to handle that. But in case of this VMX mode configuration there, my my guest OS would kind of think that I'm super user, super admin, or whatever, right? And it can basically behave like it has entire hardware access, but internal it does not have. So this is how it looks like if you look at here. What is happening is, think about, there are ring 0 to ring 3 for the underlying hypervisor, and we have ring 0 to ring 3 for my guest OS here. What happens with the VMX mode when I configure, right? When I configure the VMX mode, the registers what I have in the CPU, they can be set with respect to the guest OS or with respect to the hypervisor as the requirement comes in. So in general, when I'm going to have the registers under my configuration, I would kind of understand, okay, I have the full access, and that is going to be much more better and faster for me. That is what is happening in terms of this virtualization method, in which you have 4 additional rings for the guest OS. But being said that, the access to the underlying hardware would again be controlled by the ring 0 of the hypervisor, which means, so when you want to access over the network card and all that stuff, that is still happening by the hypervisor. But what is the benefit of this particular part is, because when I'm going into VMX mode or coming out of it, the registers what I have on my CPU, they reflect the right values of the VM or the guest OS. So in that case, they work effectively better and faster. Correct? So if this is too much kind of thing for you, you can just think about as a default thing that now all of the virtualization is being done typically by the VMX mode in the environments. That is what being primarily also used in the production as well. Okay. So now in terms of Linux, we have, so when we want to configure the virtualization on Linux, we can use the software of KVM kernel module and QEMU as a process to create these VMs for us. So now you can use QEMU is a user-space program that can create VMs. So if we have configured the KVM kernel module, and this kernel module implements the VMX mode for Linux, if it has been enabled, it's perfectly fine. We would use the VMX mode configuration. If not, then we can use the full virtualization method or binary translation to run the QEMU, or we can kind of run our VMs by the QEMU itself. So if you deploy QEMU and if you have KVM, then you can run in the VMX mode. Or if you don't have KVM, then in that case also QEMU can run your VMs, but it would be in the full virtualization method, which is going to be slower than the regular case of the VMX mode there. Hope this makes sense. Okay. Now in Linux, we have this libvirt API. So if you install this software like virtualization of that's also a case there. But if you are running locally on with the help of KVM QEMU, you require a way to manage those VMs. And for that, we have a program called Virsh, VIRSH. It's a client program. And then we have a UI, which is Virt Manager. These both uses the libvirt API to communicate with the QEMU. So libvirt program can communicate with other hypervisor as well. But in terms of Linux, typically going to communicate with your KVM or QEMU to deploy the VMs for you. Okay, so this is what we discussed about typically in terms of the CPU virtualization. But then we look at also how we can do memory virtualization as well, and then IO as well in the next slide there. So if you look at in terms of the way OS works is, we basically take whatever the RAM we have, we would take those RAMs and convert it to pages, and then we'll map those pages to respective programs or the OS what we have. So here we are kind of talking about in terms of the VM and the host system. So if you look at here, the entire RAM is going to be available for the host system or the VM what we have there, right? Now, whatever RAM we have, that is the physical So we are going to divide that physical RAM into pages at the VMM level. And then we are going to have these different VMs which we are running. And these VMs are going to have their own. So for example, if we are going 2 GB RAM to a VM, right? Now that 2 GB RAM, what we have given to the CPU or given to that guest OS, right? That 2 GB can map to the entire system somewhere. Maybe it can be 32 GB machine or whatever it is, right? But it can map anywhere else in the system, right? So now the guest pages what we have, they somehow need to map to the host system pages as well, correct? And there can be multiple VMs what we can have. And if every VM of 2 GB size and whatever, right? 2 GB RAM there, right? So in that case, the page of the virtual machine would map one page on the physical machine as well somewhere, correct? So again, this is what we call as a memory virtualization, in which we have like 64 GB machine on my system, and then we can carve out 2 GB RAM to my VMs, and those VM pages can map to anywhere on my host system RAM there. Then we have IO virtualization. So as you can think of now, you can basically, you may be having network cards, display cards, hard disk, and so on, right? Now, all of these hardware, keyboard, mouse, and all that stuff, they need to work with the different VMs simultaneously in a way, right? So what can happen is we can give the access to our resources or the hardware in two different methods. One is called emulation, in which our hypervisor emulates the devices for different VMs what we have. So you have one network card, it is going to emulate different network cards like virtual network cards for different VMs. So the guest OS would talk to its own whatever the network card is there, but eventually it will come to the same network card of the host system and then go out of the environment of yours. So that is called as an emulation, where the virtual machine hypervisor or the VMM virtualize the hardware and give it to individual VM there. But then we have a second way of something called as device pass-through. So in this case, a slice of the hardware can directly be given to the VM. So think about, you can attach a network card to your hardware, to your system, and you can say that I'm going to completely give this network card access to my VM. And that in that case, that VM is going to have complete access of that hardware, and that can be much more faster, right? So when you virtualize the network card, it can be slower. But when you create or when you attach these network cards, kind of a say complete to a given VM, that VM can perform faster. That is the method which is being used in terms of when you buy these kind of expensive resources on AWS and so on. There you can ask for GPU, it can be attached directly and so on. And that will cost different price range would become there, right? Because you're going to have direct access of the hardware under the VM. And that we call it as SRIOV, if you have the terms there as well. So SRIOV is the same thing, that in which basically we give direct access of our hardware to the VM what we have. Okay, let's look at a few demos here, and then we'll basically look at the cloning and the other part as well, the snapshots and so on as well. Any questions, guys? Put them on the chat. Meanwhile, I'll give the demo here. Just give me a minute. So I'm currently accessing another laptop of mine, which is again going to have a Mac. And on that Mac, I have installed the VirtualBox, because in my current system, it is that M1 chip, and VirtualBox could not work. So I have to kind of take the help of other instance to the demo to you. But anyway, in this particular case, I'm using the VirtualBox here. So you can install the VirtualBox software. And then you should be able to configure a few things. Let me show you. Yeah. Let me go to the settings here. Yeah. Just hold on. Let me see if power of this machine now. Okay. So now once you have installed the VirtualBox, it looks something like this here. Now what you can do here is we can create different. Let me see if I hope this is better for you to check it out. Okay, I can't increase this. Okay, hope this is still visible to you. So what we can do here is once you have installed VirtualBox, you can click on New. And with this new, you can create an instance of your own choice. So here we are going to look at emulation here. So we would create a VM, and then in that VM, all of the CPU RAM would get emulated, and then that particular instance would get that configuration here. So here I just clicked on the new. I can give the name to it. Then I can tell you where I want to kind of save that VM information on my system here. Then I can decide which particular ISO I want to install, or like typically we take the CD-ROM, we put it on the, we take this USB disk or the CD, put on a system and then try to install it. Similarly, what I have done here is I have got, I have two ISOs here. One is the Linux called Alpine, and then second I have for Fedora. So if I click on the Alpine one, I can choose the type is Linux, and then it is a 64-bit ISO what I have. So I'll click on the next here. And then I'm going to decide how much CPU and RAM I want to give here. So I'm going to give, like, say, 512 MB of RAM. I can choose out of 8 how much CPU I want to give. I'll just say 1 CPU is sufficient for this. Continue on this. The disk size which I want to have. Now, this disk which I'm creating for my instance here, this can be basically, so if I say 20 GB here, so I may not consume 20 GB right away, but it's like a sparse disk. You use it as much you want, and then, but you can go to 20 GB here. So if I look at on my system, it is not going to a 20 GB size. It's going to, let's say, 1 GB when I'm going to install my OS and all that stuff. But it can go to 20 GB if required. So that is a benefit if I use that sparse disk. But if I use pre-allocate, then what's going to happen? Entire 20 GB going to be allocated in the beginning, which is going to be waste of resources. So typically you don't choose that and use the dynamic disk there. I'll click next here. This has given me information. I'm perfectly fine here. Whatever I've configured, some finished. And now here I can look for the configuration of it. So if I look at details of the VM, I can look into settings here. And then I can do few things here. Like I can configure the storage here. Like as you can see, I have attached the CD-ROM here, the disk, what I have here. Then I can go to system here. I can change the boot disk or boot priorities and all that stuff here. So all of these things can be done, but let's continue for now. And now if I say start, what's going to happen is it's going to create the VM instance for me. And yeah, it's kind of booting up. Let me just see if I can make it much more visible for you. Yeah, so as you can see that VM got loaded here and it is now running. That's all I'm going to show it to you here. Let me just kind of quickly set it down here. I don't want to file resources on this. Okay. Let me just log in quickly here and then do power off from here. Okay. This is going to turn off my VM what I just created. So I just showed you how we can create a VM quickly and then remove it, right? Then let me go back to the presentation. Yeah. So now to remove the instance, I can simply click on the right button, click on the button and then remove the instance. I believe that's perfectly fine, but let me see. So if I want to remove it, I can click on here and say delete, remove, and this can remove the entire VM for me. So if I say delete all files, go to remove all of my configurations as well as those disk files. So I can just quickly go and remove all of these things. Okay, fine. Now let's look at one case here, the migration, right? Now you have one physical machine on which you have deployed your hypervisor and you are running the VM instance perfectly fine. Now with the live migration, what we can do is we can move the VM from one physical machine to some other machine as well. Now, why is that can be required? It can be required because I may want to kind of take my machine 1 down for the maintenance. I want to kind of do the load distribution. For example, if the physical machine 1 has a lot of VMs running, while the physical machine 2 is relatively kind of not so busy, correct? So I can basically migrate some of the VMs from the physical machine 1 to the physical machine 2, so that I can balance out my overall VM workload there. So that can be reasons why I want to kind of do the VM migration there. Now, if you look at a step, a kind of a dig deep further here, right? When I am doing a migration, right, what all things will take care, right? So when I'm doing a migration of my VM, I would need to save the kind of entire CPU context. So for example, if I am performing a calculation of whatever number, right, and all of my values, my registers, when I do the live migration, I have to actually get all of the register values, take from here, put it to other machine, and then create my VM and make sure that that CPU have the same register which I have in the previous one, correct? Similarly, the network base, whatever the traffic was being served by VM1, when I do a migration, it has to serve the similar traffic, the same traffic, correct? The device which I have, whatever the devices I have, the network card and all those things I have on my physical machine one, when I migrate, I need to migrate the same devices also there, correct? And then disk, of course. So typically in this case, what we do is we'll have a shared disk, which is shared between. So what I'm saying is we would have a shared disk, which has been shared by both the physical machines. So when my VM moves from one to another place, the same shared disk available to other the VM on the other machine as well. So this is not a very kind of a simple problem to solve, right? Because this is happening at the live machines, at a where your live traffic is coming and so on. So there are again different methods by which you can optimize these things. There are like copy first, copy next. There are other methods out there, but I'll not go in that. But as you can understand here, the migration is possible, but for all this migration, all of these things need to be taken into account. Then we have concept of VM cloning. So now think about your you make a VM ready for yourself. So for example, you have one golden VM kind of a thing for your team, right? Or for yourself as well, right? So now what you can do is you can have that VM ready for you. Then you can clone of it, right? And then you can then have that cloned VM and you can perform different operations on that. They'll be completely different VMs altogether. So here when we say I'm going to do a clone, I want to kind of clone the similar hardware, similar software and properties, whatever I had for the previous one, I want to have the similar one there. Let me show you with an example here. If I again go to my virtual box here, as you can see, when I click on any of the machine here, I'll have an option. I'll click on the right click here and say clone. So what's going to happen is going to clone the current VM and make another copy of it with the exact same replica. So if I say clone, this is Fedora clone, perfectly fine. I'll say full clone or a linked clone, whichever I want to do here. So linked clone is done with the help of snapshots, which I'll talk about next. But here, the full clone means it's going to clone everything, and then both the VMs would not be linked at all. But in the linked clone, we'll talk about snapshot in the next topic. So I'll cover that. For now, it's a full clone. Do I want to kind of take the current state or everything? So I'll pick up what are the current state right now. And now you can see that it's going to create another cloned VM for me. What happened? Did I skip it? Let me just, yeah. So what happened? When I say clone. I think there's some time there behind the scene because yeah, it's there, right? As you can see here, the clone has now come because it has to copy the entire disk, whatever I had previously. And I have now cloned VM now. And if I start it, it's going to give me the same VM behavior as earlier. So if I click on this, it's going to start the entire Fedora environment for me. So I think I have not attached a disk to it. Let me just check what's wrong. 1 minute. Settings. Okay, I need to first actually 1 minute. I need to first. Yeah, sometimes when you give the demos, right, things kind of break. Let me just check 1 minute. I'll just see what's the problem. Go shut down the machine for now. So it's not able to find the bootable disk. That is, I don't know, shouldn't be the case. Let me see the configuration of it and then check. So system, hard disk, storage. There should be a storage attached to it, but why it is not? I think even the clone, I think I kind of doing something that got cancelled. Let me just do one more time here. I'm just going to do a clone one more time. To clone everything I'll do. Yeah. Let's wait for this particular thing to happen. I'll not touch the system. Let's see. Come on. Yeah, so now clone is here. Let me now check the configuration before I even start it. Let's see if this has got the storage. Not. What happened? What's wrong here? Let me just check. Okay, I think something is wrong. I'll maybe come back later. Okay, so I don't know what the problem is, problem with the software or problem with the hardware. I don't know right now. Okay, so let me talk about the next thing here. But you got the idea that what clone is going to do is going to create the entire copy as it is, and then it is going to perform the steps to set up the similar instance. Again, for example, what you see here is, right, there's a Fedora.vdi is there, 10 GB size is there. So either what is happening maybe is, let's see how much space I have. That may be one case here. But yeah, because we're not using the full, okay, I'll just not debug it right now. I'll do it later and come back to you. Okay, so now let's say if I talk about one more thing here called the cloning part here. Right, so now what is the cloning has been taken account. Next is I will talk about snapshots. Now, a snapshot are a way to kind of save the current state at a given point of time and then revert back to it if there is a need. So think about, for example, if you are installing a software and after doing the installation, something goes wrong. So how would you revert back to the previous state? That is where a snapshot can become handy. So what we do is we have our VM, we take a snapshot. That snapshot like a photo, whatever you think about it, take a photo, which kind of takes into account what is at that given point of time my system is. And then if something goes right, I can come back to it. So like in this case, you can see what we have done is we have one VM, we take a snapshot one, and then later I want to kind of again save the state, I'll take a snapshot two, or in this case, snapshot three, and so on. So whichever I would, I take a snapshot at any point of time and come back to it as the requirement comes. So let's see a demo of this. I think this should definitely work because I have tried that. Okay, so now what I'll do here is I'm going to start this instance first of all, and then show you that it's a regular Fedora instance. Yeah, let me just do that. view and the scale mode here. Yeah, so what you're seeing here is that our Fedora is coming up, and this should have our OS in it here. So I just wait for it to come up. Yeah, I can now log in here. I'll give my password. And let me just start a terminal here. Terminal, yeah. Now what I'll do here in this particular case, this particular instance, what I have done, I have installed the Fedora on this, and then after installing the Fedora, I have taken a snapshot, which I'll show you how you can take it. But for now, let us now try to, let's say, install a package in this, and then we will take a snapshot after that, and then see how we can kind of take into account. So what I'll do is I'm going to install a package here. Let's say it's not apt, it's going to be yum, right? So yum install Apache 2. Okay, I need to be sudo. And I'll install, let's say, nginx package here. Yeah. I'll give the password. Yeah. So now what's going to happen now? This is going to install the software of nginx for me, and I should be able to configure. I'll just say yes. This is good. So I've installed it, right? And now let's say if I do system CTL CTL status nginx. It is currently loaded but not running, so I'll make it active. So I'll just say start. Yeah, so it should be now running here. It is now running here. And if I do curl localhost, I should get the welcome to nginx page. Yeah. Sorry, localhost spelling. Yeah. So you can see that I'm getting some kind of a page here, which is not very clear, but you can see there is some kind of web pages coming for me. And now what I'll do is I'm going to do enable it as well. Right. So my nginx is now being configured to run at the boot time. Perfect. Now what I'll do is I'm just going to shut down the instance here, power off the machine. The machine is now powered off, and so that has been into account. And if I start, it's going to start with that particular engine software installed here. Let me 1 minute. I want to show you snapshot here. Settings. Yeah. So yeah, snapshots, right? So you can see here, I have taken the snapshot at the time of when I have just installed my my system. And now you can see that I have the VM installed. I have the VM, and in that VM, we have installed the nginx. And if I start it, you will definitely see that nginx as a part of it. So that is there. So if I start the VM, we would have the by default nginx running in that. Let me go back to that mode again, scale mode, boot. And I want to show you there is once I have basically have the snapshot which I was running previously, I'll go back to the previous snapshot, and then we'll see that this particular package would no longer exist in that. Let me first show you that. There. Okay, so what happened is Yeah. So you can see now at this point of time, I just need to start a service here. But as you can see that my Nginx was installed here, and I could basically connect with it, right? Now what I'll do is I'm just going to shut down the machine again, and then I'll go back to the setup just after the fresh installation of it. Let me shut down the machine for now. And now what I'll do is here, I can say that restore the snapshot of the previous version. So let me just do a restore. And let me just do the restore part here for now. Snapshot with, so I'll just, so what is asking us right now is because our state of the system is changed right now, whether you want to save that state right now, because we install Nginx on that, they're asking whether I want to save that state or not right now. So I'll say yes, I'll do that. So I'm going to say Nginx snapshot is there, correct? And now if I kind of restore back, I think it's already done here. And now it has become in parallel here. So let me now start the instance here. So will come up. Okay, come on, let it come up quickly. So what we'll see here in this particular snapshot, we would not have the software of Nginx installed in this. So if I do it here, terminal. GTL start Nginx. So you can see it is saying that fail to start Nginx because Nginx software is not available here. So what happened is, let me, if I want to picturize that a bit for you. So let me go to the presentation earlier, what I had. So think about after getting the VM installed, I have taken the snapshot here. Then after from that snapshot, I can create. Okay, so let me come back to, yeah. So I've installed my VM. I have taken a snapshot. Perfect. And now what I can do is I can basically start the VM instance again. So I run the VM, and in that VM I've installed the Nginx and it make it run. But what happened is after that, I would basically revert back to the snapshot one, which was just after the installation part of it. So I kind of came back to it. This is very important when you take, like, when you want to make sure that your system is going to be in a stable state, right? Or you want to make sure that you don't lose something if you perform the next operation. As I mentioned, if you are installing a software, you want to make sure that when you install the next software, it should not break your system. You want to be sure for that, right? What you do is take a snapshot at this point of time. You install something, if everything goes well, continue forward. Otherwise, you say revert back, correct? So now you can take the snapshot at the running time as well or the stop state as well. So whichever you prefer, you can take snapshots. And this is a very popular feature in different cloud providers. So you can take snapshots at any point of time, and that's going to save the state of your VM at a given point of time. And that basically help us in the overall sysadmin work, what we do in our day in the industry there, right? Hope this makes sense. Any questions you guys have? No? Okay. Was this webinar was useful or not? I mean, how did you find the webinar? I mean, did you get something new to learn or not on this webinar? Okay. I know this may sound a bit not so very useful, but if you kind of go to build your own cloud and so on, you'll understand how much all of these things come and play together, right? So think about the load balancing between two different regions and all that stuff, right? They all done on top of the VMs what we have, right? Yeah, okay. Hope to, if there are no questions, we are good. If you have any questions, do reach out to me. I'll be happy to answer. And I'll see what I can answer you for. I mean, that clone should have worked. You can try out locally. If it doesn't work, you can let me know. We can kind of try to solve it. I'll also see that what is happening in my clone setup and why it will not work. So I'll check, and if time permits, I'll get back to you guys. Yeah. Okay. Thank you. Thank you very much. Bye-bye.